Let's compare the rate of decay of two isotopes which are both beta emitters. Remember that every time the nucleus of an atom decays, it releases a beta particle. The first isotope has nuclei with a high chance of decay. It's very radioactive to begin with, but a few seconds later, it's much less radioactive. And this is because it quickly runs out of nuclei that haven't decayed yet. The second isotope has nuclei with a much lower chance of decay. It's not very radioactive. But this low radioactivity continues for quite a long time. And this is because the number of undecayed nuclei stays high for longer, or if you like, it runs out of undecayed nuclei slower. There's always this trade-off. If an isotope has what we call a short half-life, then it's very radioactive, but not for very long. If an isotope has a long half-life, then it's not very radioactive, but for a long time. It's impossible to be both very radioactive and to have a long half-life. So what is half-life? You can see that the number of undecayed nuclei goes down in a curve, not a straight line. In a real sample, there'd be trillions of nuclei, so there isn't really a time when they all run out. Instead of thinking about the nuclei decaying, let's think about the beta particles given off. We can measure these using a Geiger counter, but we can't count the nuclei directly. If in 1 second 10 nuclei decay, then 10 beta particles are given off. So we can use the graph of radioactivity over time, and it will have exactly the same shape. Here's an isotope that emits alpha radiation with a half-life of 10 years. As we go forward in time, we can see it gets less and less radioactive. But why do we say its half-life is 10 years? It's because the radioactivity decreases by half every 10 years. It takes 10 years to go from 80 becquerels to 40 becquerels. Another 10 years to go from 40 becquerels to 20 becquerels. Another 10 years to go from 20 becquerels to 10 becquerels. And another 10 years to go from 10 becquerels to 5 becquerels. Most people think that half-life tells you only how long something is radioactive for. But it's important to remember that half-life also tells you about how radioactive something is. The longer the half-life, the lower the radioactivity.